Building giants, moving mountains. The heavy industry world turns raw power into breathtaking feats of engineering. The drilling process begins with the bow rotary drilling rig being positioned precisely at the marked location. Workers then guide the drill casing vertically to ensure alignment. Once set, the rotary drive starts operating, rotating the drilling tool and driving it into the soil. As the tool penetrates deeper, spoil is brought up and removed from the hole. The rig continues drilling in stages, pausing periodically to extract excavated soil using a clamshell or auger tool. Steel casing is added segment by segment to maintain borehole stability, particularly in loose soil layers. These casings are screwed or pressed into the ground using the rotary drive. Drilling progresses until the designed depth is achieved. Throughout the process, workers monitor alignment and depth using measurement devices mounted on the rig. Once the final depth is reached, the drilling tool is withdrawn, and workers prepare for reinforcement cage installation. The prefabricated steel rebar cage is lifted using a crane and slowly lowered into the borehole, ensuring it remains centered. Guide frames or spacers are used to maintain cage position inside the casing. Finally, concrete is poured using the Tremie method. A Tremie pipe is inserted to the bottom of the hole and gradually lifted as concrete is pumped, displacing any remaining drilling fluid or loose soil. This ensures continuous and clean concrete placement. After concreting is complete, the temporary casing is withdrawn, completing the pile construction, dan N. The engineering method used in port construction and coastal protection, focusing on the transportation and immersion of caissons. Caissons are large, hollow concrete blocks used as foundations for marine wharves and breakwaters. In this method, marine rubber airbags play a crucial role in lifting and moving these massive structures safely and efficiently. The process begins with positioning the inflated rubber airbags beneath the caisson on land. By adjusting the air pressure, the airbags lift the heavy structure slightly off the ground, allowing it to roll smoothly toward the water using controlled movement. This airbag transportation technique eliminates the need for cranes or rail systems, reducing both cost and risk. Once the caisson reaches the launching area, it is carefully floated or lowered into the sea for final placement. Engineers then submerge the caisson to its designed underwater position with precision. This airbag-assisted transport and immersion method has become a reliable, eco-friendly, and cost-effective solution widely applied in modern harbor and coastal engineering projects. The Zourite is a heavy-lift jack-up barge specially designed for the offshore installation of a viaduct on the French island of La Réunion. This impressive vessel played a crucial role in constructing the coastal road bridge known as the Nouvelle Route du Littoral. The barge is equipped with 4 enormous legs that can be lowered to the seabed, allowing it to jack itself up and create a stable working platform above the water surface. This feature is essential for precise operations in challenging marine environments. Zourite is capable of lifting and positioning massive precast bridge segments, each weighing hundreds of tons. Using its powerful cranes and advanced control systems, the barge can transport and install the segments with remarkable accuracy, even in strong ocean currents and winds. The barge's stability and lifting capacity made it possible to assemble large sections of the viaduct directly offshore, minimizing the need for temporary structures. Through this advanced heavy-lift system, the Zourite barge greatly improved efficiency, safety, and precision in marine bridge construction. It stands as a key example of modern engineering innovation used to overcome complex offshore construction challenges. The SpaceX drone ship returned to Port Canaveral on Monday, November 19, 2018, carrying the Falcon 9 first stage that had successfully launched the ESAIL-2 satellite into geostationary transfer orbit. On the first day, the booster's arrival was observed without much further activity. The next day, SpaceX engineers lifted the booster from the drone ship and placed it securely on a stand for inspection and processing. On the third day, the recovered stage was lowered to a horizontal position and loaded onto a transporter for further transport to SpaceX facilities. This careful recovery and handling process highlights SpaceX's commitment to reusability and efficiency in modern spaceflight operations. PTC Fiat Group is a world-renowned French company specializing in innovative foundation and soil improvement equipment. The company offers a complete range of solutions, including free-hanging vibrodrivers, excavator-mounted vibrodrivers, offshore vibrodrivers, piling rigs, vibrolances for soil compaction, and equipment for stone column installation. All PTC machines are 100% made in France and are recognized for their precision, durability, and performance. As the inventor of variable moment technology, PTC holds multiple international patents that have revolutionized vibration control and efficiency in piling operations. Every product undergoes strict quality control under the ISO 9001 quality management system to ensure reliability and safety. Each unit is fully tested before delivery and features advanced parameter settings for optimal performance in various ground conditions. Through decades of innovation, engineering excellence, and commitment to sustainability, PTC Fiat Group continues to set global standards in foundation equipment manufacturing and soil improvement technologies. The advanced production facilities of the Chelyabinsk pipe rolling plant and the Pervouralsk new pipe plant, now part of the TMK Group. CHTPZ includes the Vysota 239 workshop for large-diameter pipes and the Eterno workshop for high-tech fittings. At PNTZ, the finishing center ensures precise product processing, while workshop number 7 handles seamless pipe production. The Iron Ozone Electric Steelmaking Shop produces high-quality steel billets, forming the foundation for the group's modern pipe manufacturing chain. The Liebherr LB36 is a high-performance rotary drilling rig designed for demanding deep foundation works, such as caisson drilling, pile foundations, and soil stabilization. In this project at Toronto Pearson International Airport, the LB36 is employed to drill large-diameter caisson shafts with casing, forming part of the airport's foundation infrastructure. Its exceptional torque, stability, and versatility make it ideal for the complex geotechnical conditions encountered on site. The LB36 is part of Liebherr's advanced LB series of drilling rigs, known for their modular design and superior engineering. The rig's main advantage lies in its ability to perform a wide range of drilling techniques, including Kelly drilling, continuous flight auger drilling, partial or full displacement drilling, double rotary drilling, and soil mixing. In caisson drilling applications, it can be fitted with a casing oscillator powered by the machine's onboard hydraulics to install large diameter casings and maintain borehole stability in loose or unstable soil layers. During the caisson drilling operation at Pearson Airport, the LB36 demonstrates its outstanding power and control. The model LB36-410 can deliver a torque of up to 410 kN, providing the force needed to penetrate compacted soils and rock layers. Its powerful Kelly winch and rope crowd system allow for precise vertical movement and steady drilling progress, even in challenging conditions. The rig's robust leader design ensures optimal alignment and stability throughout the process, which is essential when drilling deep shafts for structural foundations. Another significant feature of the LB36 is its advanced operator assistance system, which enhances productivity and safety on site. The CAD is equipped with an intuitive control interface, allowing operators to monitor drilling parameters in real time. Functions such as automatic torque regulation, cruise control, and automatic shakeoff minimize manual intervention and help maintain consistent performance. The leader inclination memory assists in achieving accurate positioning of the tool, ensuring that the boreholes remain straight and within design tolerances. Additionally, features like Eco Silent Mode and automatic engine stop reduce fuel consumption and noise emissions, making the machine more environmentally friendly and suitable for operation in urban areas like Toronto. The design philosophy of the LB series emphasizes durability, flexibility, and ease of maintenance. The modular construction allows for parts interchangeability between models, such as the LB28 and LB36, which simplifies logistics and reduces downtime. The rig's heavy-duty undercarriage and adjustable tracks contribute to exceptional stability during drilling and casing oscillation operations. These features, combined with Liebherr's engineering precision, provide the reliability required for long working shifts in demanding field conditions. At the Pearson Airport construction site, the LB36 plays a crucial role in creating deep caisson foundations that will support critical infrastructure. The use of casing ensures the integrity of boreholes in water-bearing or collapsing soils. The rig's hydraulic casing oscillator, synchronized with the drilling system, allows for simultaneous drilling and casing installation, preventing soil collapse and maintaining borehole alignment. Once the desired depth is reached, the borehole is cleaned, reinforced with steel rebar cages, and concreted, forming the permanent Caisson foundation. In conclusion, the Liebherr LB36 rotary drilling rig exemplifies modern foundation engineering technology. Its combination of raw power, intelligent control systems, and adaptable configuration makes it an indispensable tool for large-scale foundation projects such as those at Toronto Pearson International Airport. With its proven performance in Caisson drilling and other foundation methods, the LB36 continues to set a benchmark for efficiency, reliability, and environmental responsibility in the construction industry. The Valhall QP topsides removal project demonstrates the precision and lifting capability of the pioneering Spirit, the world's largest construction vessel. Operating in the Valhall field in the North Sea, the mission began with the vessel moving backwards into position to remove the bridge connecting the accommodation and drilling platforms. Using its massive lifting beams, the bridge was detached and carefully lifted onto the vessel's deck. Following the bridge removal, Pioneering Spirit was repositioned to prepare for the main operation, the removal of the QP topsides. The vessel's twin bows surrounded the platform, allowing the lifting system to be precisely aligned beneath the structure. Then, the first two yokes were positioned and raised under the platform, followed by the activation of the active motion compensation system. This advanced system synchronizes the vessel's movements with the sea conditions to ensure stability and prevent structural stress during connection and lifting. Next, the yokes were connected to the platform, securing the load. The second pair of yokes was then carefully positioned and connected, completing the full 4-point attachment. With all yokes engaged and the structure stabilized, the vessel executed its signature fast lift operation, a near instantaneous lift that cleanly separated the topsides from its supporting jacket. Once the topsides were safely clear, Pioneering Spirit moved away from the jacket, carrying both the bridge and the platform topsides. The vessel then sailed to Stord, Norway, where the dismantling and onshore transfer were to take place. Upon arrival, the bridge was lifted onto the quayside, while a cargo barge was positioned in the vessel's slot for the topsides load-in. After disconnecting the yokes, the heavy structure was transferred onto the barge. Marks the completion of an operation that has safely removed the QP topside and bridge from the Aker BP-operated Valhall field in the southern Norwegian North Sea. Weighing just 3,800 tons, the QP topside is the lightest rig that Allsea's record-breaking vessel has ever lifted. The successful lift further demonstrates the operational capability and versatility of the world's largest construction vessel. The Delhi-Mumbai Expressway is one of India's most ambitious infrastructure projects, designed to connect the national capital New Delhi with the financial hub Mumbai. Spanning approximately 350 kilometers, The expressway features an 8-lane access-controlled design, with the potential to expand to 12 lanes in the future. It aims to significantly reduce travel time between the two major cities from around 24 hours to just 12 hours. On February 12th, Prime Minister Narendra Modi inaugurated the Sohna to Bonli section of the expressway. This newly opened stretch has already made a major impact by cutting the travel time between Delhi and Jaipur to about 4 hours. Motorists heading to Jaipur can conveniently exit at kilometer 180, where the route connects with the Agra-Jaipur highway near Dausa. The Delhi-Mumbai Expressway is expected to transform road connectivity, boost trade and tourism, and contribute to the economic development of multiple states along its route. The Appomattox platform is recognized as the largest offshore oil platform ever built, a triumph of modern engineering located in the Gulf of Mexico. Constructed by Shell, it represents a milestone in deep water production. Designed to operate safely and efficiently for the next 40 years in one of the harshest marine environments on Earth. Weighing over 124,000 tons, Appomattox is a floating city capable of producing up to 175,000 barrels of oil and gas per day. The structure consists of 4 massive columns supporting living quarters, power generation, process modules, and utilities. It is anchored in 400 feet of water, a depth that required the development of highly advanced subsea systems and robotic technologies. The installation process involved extraordinary precision. Engineers aboard the vessel Balder welded and laid over 200 miles of subsea pipeline, aligning connections within half a millimeter. A subsea tree weighing as much as a space shuttle was lowered nearly 7,400 feet to the seabed and landed on a target less than half an inch wide. Appomattox began producing oil in 2019 after 7 years of engineering, fabrication, and offshore integration totaling over 15 million man-hours. Designed to withstand hurricanes and 100-mile-per-hour winds, it combines strength, flexibility, and cutting-edge automation. For everyone involved, from welders to engineers, seeing oil finally flow marked not only the completion of a colossal project, but also the beginning of a new chapter in deepwater energy production. An enduring symbol of human ingenuity at sea. The construction project in Bessegheim involves building a replacement bridge for the B-27 crossing the Enns River near the town entrance. The abutments and bridge piers are founded on cast-in-place concrete piles with a diameter of 120 centimeters and lengths ranging from 9 to 15 meters. At one abutment, a secant pile wall with 90 centimeters board piles is also installed. Sheet piles are used for excavation support. The foundation works are carried out with the LB-28-320 drilling rig, while an LRB-125XL handles the sheet piling. The main challenges include working near the riverbank and maintaining traffic under partial road closure on the B-27. The Caisson Vario J-hook is a specialized lifting device developed for the safe and efficient handling of wind turbine tower segments. Its main functions are lifting, turning, and serving as a stop device during unloading. The newly designed J-shaped hook features a patented inner shell with plane bearings, which rotates together with the tower flange during the turning process. This innovation ensures a gentle rotation without introducing bending forces into the flange. All contact surfaces are protected with durable Secutex impact protection, keeping the flange secure and undamaged. The externally positioned pivot point allows the Vario J-hook to accommodate flange thicknesses from 60 to 220 mm and heights from 200 to 600 mm, offering exceptional versatility. It also provides considerable time savings, as it can be removed directly by crane after lifting without time-consuming dismantling. Unlike conventional attachment points that require working beneath suspended loads, the Vario J-hook enhances both safety and efficiency. Additionally, an optional bracing system enables even soft tower sections to be lifted and turned without deformation. This makes the Caisson Vario J-hook an advanced, reliable, and time-saving solution for modern wind tower assembly operations. The IPA Steel Terminal at Altamira is a specialized heavy lift facility designed to handle massive steel and industrial cargo with precision and safety. In this operation, the terminal managed a remarkable 565 metric ton lift related to the oil and gas sector, showcasing its impressive capacity and expertise. Equipped with 2 cranes, each capable of lifting up to 100 metric tons, the terminal ensures efficient handling of oversized steel structures, modules, and components. Its advanced infrastructure and skilled workforce enable smooth coordination during complex lifting operations. The successful handling of this 565-ton load demonstrates the terminal's ability to support demanding industrial projects, including those in the oil and gas industry. With a focus on reliability, safety, and heavy lift excellence, the IPA Steel Terminal Altamira plays a vital role in supporting large-scale logistics and energy sector operations across Mexico and beyond. The transport of a massive jack-up drilling rig from Vietnam to the United Arab Emirates marked one of the most remarkable achievements in Martin Bencher's history. This operation involved the heaviest single unit ever handled by the company, with an impressive transit weight of 16,160 tons. The offshore rig measured 93 meters in length and 66.5 meters in width, featuring 3 towering legs, each extending up to 148 meters. The rig was loaded at the port of Vung Tau, Vietnam, and shipped to Dubai, UAE, completing its ocean voyage in 18 days. The successful transport required careful planning, engineering precision, and coordination between port authorities, marine experts, and logistics teams. Every step of the operation was executed with strict safety measures to ensure the stability of the oversized cargo during transit. With more than 10 years of experience in the oil and gas industry, Martin Bencher has established itself as a global expert in handling overdimensional and heavy lift cargo. The company operates its own offices in major logistics hubs worldwide, providing first-class shipping solutions for complex industrial projects. This project perfectly showcased Martin Bencher's expertise, professionalism, and commitment to delivering exceptional heavy lift logistics services across international waters.